3.3 Lesson 2, Derivative Functions Numerically and Graphically. Objective. Given the graph of a function f, you will be able to sketch the graph of f prime, the derivative of f. This is read f prime, and it represents the derivative of the function f. So vocabulary, derivative, and what does it represent? Graphically, it represents the slope of a tangent line to the graph of f at a particular point. In the context of a word problem, the derivative would represent an instantaneous rate of change. So here we take a look at a problem, number 7. Sketch the derivative graph on a copy of the given graph. So we're given the graph of the function f, and we'd like to sketch the graph of f prime, the derivative of f. To do that, we will go back to what we learned about the derivative. It represents the slopes of tangent lines to the graph of f at different points, at various points. What I can do is I can complete this table where for different values of x, I will draw tangent lines to the graph of f and then estimate the slope of each of those tangent lines to get the value of the derivative at each of these x values. And then I will plot these points from my table for f prime, and I will connect those points with a smooth curve to get the graph of the derivative of f. I would like to start with the point 1, 5, where x is equal to 1, because I see that at that point, the tangent line to the graph of f is horizontal. The slope of this horizontal tangent line will be 0, which means f prime of 1 would be equal to 0. And I would write 0 for my table. Now, I would like for you to observe that for x values that are less than 1, so when we're looking at x values between -4 and +1, you can see that the graph of f is rising from left to right. The function f is increasing. And if you draw tangent lines for any x value that's less than 1, the tangent lines will be upward sloping, which means that the tangent lines will have positive slopes. So on the x interval from -4 to 1, I will have positive values for my derivative. And on the x interval from 1 to 6, if you look at the graph of f, it is falling from left to right. The function f is decreasing. The tangent lines will be downward sloping, and they'll have negative slopes. So for these x values of 2, 3, 4, and 5, I'm expecting my derivatives to be negative. And this is what we learned yesterday. When you have a function that's increasing on an interval of x values, its derivative will be positive on that interval of x. And when you have a function that is decreasing on an interval of x values, its derivative will be negative on that interval of x values. So now we're looking at where x is equal to -3 on the graph of f, and I drew the tangent line to the graph of f, and I will go ahead and approximate the slope of this tangent line just by using 2 points on the tangent line. So here I have the point of tangency, -3, 0, and I can choose another point on the tangent line. And here's a point on the tangent line whose coordinates appear to be -2, 3. So find the slope of this tangent line by finding the difference in the y coordinates, 3 minus 0, divided by the difference in the x coordinates, -2 minus -3. So I have 3 over -2 minus 3 is +1. So the slope of this tangent line is about 3, and I would write f prime of negative 3 is equal to 3. So I complete my table here by writing a 3. Notice that when I found the slope of this tangent line, I'm using 2 points that are on the tangent line. The first point, called the point of tangency, also happens to be on the graph of f, but the second point is on the tangent line. It is not on the graph of f. So now I'd like to look at where x is equal to negative 2. I drew my tangent line to the graph of f, and I would now like to approximate the slope of this tangent line. If possible, I'd like to choose to work with what we call a lattice point. A lattice point is where you have two grid lines on the graph meet. So I chose to work with this particular point on the tangent line with coordinates negative 5, negative 2. The other point would be the point of tangency, and now I can find the slope of the tangent line. How do you find the slope of a line? You take the change in y and divide by the change in x, and that gives us 4/3 for the slope. So the derivative of the function f evaluated at x is equal to negative 2 will be 4/3, the slope of that tangent line. So I'm going to write 4/3 here for my table. This is the table of values. This is the table of ordered pairs for the function f prime, the derivative of f. If you look at this point here on the graph of f, the x-coordinate is negative 1. The y-coordinate is a little bit less than 4. It's a little bit less than 4, but let's go ahead and draw the tangent line. And let's see, we're just, again, interested in making an approximation. So even though the y-coordinate is not exactly 4, it is pretty close to 4, so it'll give us an approximation. So this wouldn't really be the point of tangency because I know it's not on the graph of f, but I am just doing an approximation for the slope of this tangent line. So I'll go ahead and write negative 1 for x and about 4 for y. And then here I have negative 4 for x and 0 for y. The slope of the tangent line would be the change in y divided by the change in x. So I get 4/3 once again, but it's actually a little bit less than 4/3. So maybe I would like to get a somewhat more accurate approximation. So I'm just trying to do a better approximation here because I don't think it's 4/3. It's probably less than 4/3. So I'm using the tangent line that I just sketched now. I'm using these 2 points. Neither of them are the point of tangency. So the slope here would be change in y divided by the change in x. So 6 minus negative 1 is 7, and 1 minus negative 6 is 7. 7 over 7 is 1. And now I'd like to get the slope of the tangent line to the graph of f at x is equal to 0. So the slope of this tangent line is about 3/5. I already have the slope of the tangent line at x is equal to 1, and I need to do this 4 more times. So there is the tangent line at x is equal to 2, and I'll use 2 points on the tangent line that are lattice points. So I have 6, 2, and maybe this one here, which is about 0, 6. So my approximation for the slope of this tangent line would be 2 minus 6, change in y, divided by the change in x. 6 minus 0. 2 minus 6 is negative 4 over 6, which is about negative 2/3. Because I am drawing the tangent lines by hand, and my tangent lines may not be 100% accurate. That is the reason why I'm saying I'm finding approximate values for the slopes of the tangent lines at these x values. So here I find the slope is negative 7, 6. I've drawn the tangent line to the graph of f at x is equal to 4. Let's find 2 points on the tangent line. Maybe this one here, 7, negative 3, and perhaps this one here, 3, 4. And we'll find the slope of this tangent line. We'll approximate it by using these 2 points. So this tangent line has a slope that's approximately negative 7 over 4. Let's draw the tangent line to the graph of f at x is equal to 5. We'll find a couple of lattice points, maybe this one here, maybe this one here. So this point has coordinates 3 for x and 5 for y. This one has coordinates 7 for x and negative 4 for y. And we'll use these 2 points to approximate the slope of the tangent line. So that tangent line would have a slope that's approximately negative 9 over 4. Now we can take these ordered pairs that we know are on the graph of f prime. We can plot these ordered pairs, and that would give us points on the graph of f prime. And then we can connect these points with a smooth curve, and that would give us the graph of the derivative. So I plot negative 3, 3. I plot negative 2, 4/3. I will plot negative 1, 1. I will plot 0, 3/5. I will plot 1, 0. I will plot 2, negative 2/3. I will then plot 3, negative 7, 6. 4, negative 7 over 4. And then 5, negative 9 over 4. So I get these points. Now there is one point that seems a little bit off. If you look at most of my points, they seem to lie on a line. There is one point that seems to be a little bit off, and that's this one here. So maybe I'd like to just double check my work for the slope of the tangent line at x is equal to negative 3. So I will redraw my tangent line to the graph of f at x is equal to negative 3. And perhaps the slope is closer to positive 2 than it is to positive 3. Again, I'm just visually estimating here, so it could be that the slope is about positive 2. So maybe that's about positive 2, and I'll plot the point negative 3, positive 2 there. And now you can see that when I take these ordered pairs and I plot them, I get a pattern that appears to be linear. So I'll go ahead and sketch this line segment. And that would be the graph of the derivative function. That would be the graph of f prime. And I have 2 open circles at x is equal to negative 4 and at x is equal to positive 6. You can see that the function f is not defined at those values. So we can later talk about one-sided derivatives, but we're just going to leave open circles there for now. So what should you walk away with from this example? Understanding that the derivative of a function tells us slopes of tangent lines to the graph of the function at various x values. And we did some work here with slopes of tangent lines. We plotted the ordered pairs that we found, which would be on the graph of f prime, and we connected them, and we got a line segment for the graph of f prime. And something more significant for you to understand is at x is equal to 1, the graph of f has a horizontal tangent line. So the slope of a horizontal tangent line is 0, and the value of the derivative at x is equal to 1 is 0, and the graph of f prime has an x-intercept at x is equal to 1. For values of x that are less than 1, you can see that the function f is increasing, so the tangent lines would be upward sloping and have positive slopes, and you can see that for those x values, the derivative values are positive. And then for values of x that are greater than 1, you can see that the function f is decreasing, so the tangent lines will be downward sloping and have negative slopes. And you can see that here. So again, to reinforce what we learned yesterday, when you have a function f that is increasing on an interval, the derivative will be positive on that interval. When you have a function f decreasing on an interval, the derivative will be negative on the interval. And of course, when the derivative is positive, the graph of the derivative will be above the x-axis. And when the derivative is negative, the graph of the derivative will be below the x-axis. And also notice that for x values that are close to 1, like 0 and 2, for x is equal to 0, the derivative is positive, but it's pretty close to 0, because if you look at the tangent line at x is equal to 0, it's upward sloping, but it's closer to being a horizontal tangent line than the one at x is equal to negative 3. So the slope of this tangent line, it'll be positive, but it will be closer to 0 compared to the slope of the tangent line at x is equal to negative 3. And that's why you get that graph for the derivative function. So today we looked at this objective. Given the graph of a function f, you'll be able to sketch the graph of f prime, the derivative of f. And we were able to do that by understanding that the derivative of a function tells us slopes of tangent lines to the graph of the function.